Hello students, this is Devarshana Raut, lecturer in computer science. In our previous slides, we have discussed about some of the types of display. We have discussed the working principle of CRT and something about LCD. In this slide, we will be discussing about working principle of LCD, that is liquid crystal display. Liquid crystal can adopt a twisted up structure, and when we apply electricity to them, they strengthen out again. This is the key how the LCD display turns on the pixels and turns off the pixels. The polarization property of light is used in LCD screen to switch its colored pixels on or off. At the back of the screen there is a bright light that shines out towards the viewer. In front of this there are the millions of pixels, each one made up of smaller areas called subpixels that are of red color, the green color and blue color. Each pixel has a polarization glass filter behind it and another in front of it. At 90 degrees, normally the pixels look dark, but when it is when the light passes through it, then we are able to see the image. In between the two polarization filters, there is a tiny twisted pneumatic crystal that is switched on and off electronically. When the voltage is provided, it is switched off, that is the pneumatic crystals stand erect and the light or the backlight is unable to penetrate the polarization glasses and we see the dark pixels. But when the voltage is not applied, the pneumatic crystals are in twisted form and the light passes easily from the polarization glasses. When it is switched on, it rotates, that is, when it is switched on, it rotates light, passing through it through 90-degree effectively, not allowing the light to flow through the two polarization filters and making the pixel look dark. When the voltage is off, the light passes effectively and glows the pixel and make the image visible to us. Let's see the same thing with a diagram. Here is the backlight. Backlight can pass when the pneumatic crystals are not provided any voltage, so it is in twisted form. It enters it enters through the vertical polarization glasses and get twisted and comes out of the horizontal polarization glasses very easily. There is a filter and a color filter, and this makes the filter glow and we are able to see the image. Whereas when the voltage is provided, the pneumatic crystals stand erect and the backlight is unable to pass through the polarization glasses and we see the pixels not glowing. So at this state, off state, it is transparent, and the on state, voltage on state, it is opaque or dark. Let's see some types of LCD. There are basically three types of LCD: direct display, direct address display, passive matrix display, and active matrix display. So let's start with the direct address display. When the display include limited variable components such as in watches, calculators, this simple electronics are used to control the components. Whereas there is one battery and each component um, holds one pixels here, so it makes um, we can see those in the digital watches and the calculators, these examples. Next is active matrix technology. It allows very high resolution. Each subpixel is individually controlled by an isolated thin film transistor, that is TFT. It allows the electrical signal for each subpixel to avoid influencing adjacent elements. The TFT is patterned into a glass layer. This is how the active matrix technology works. Next is the passive matrix technology. The passive matrix display has rows of electrodes on one piece of glass, columns of electrodes on opposing piece of glass, complex electrical waveform to control the voltage differential at intersection of the electrodes. The intersection of columns and rows are the pixels. So here in the active matrix display, each and every pixel is controlled by one transistor, whereas here in the passive matrix display, there is the intersection of rows and columns, and this intersection of rows and columns makes some mm, um, grid type of structure, and this particular grid is 1 pixel. Next, let's come to LED display. The LED display means light emitting diode display. It is the screen display technology that uses a panel of LEDs as the light source. So here the backlight source is the LED light source, and most over all the points are similar to LCD structure. Beside that, uh, we have the transistor. We have an additional transistor here, and this is known as TFT. Here we have discussed in our active matrix display, that is the thin film transistor. In LEDs, each and every pixel is controlled by one transistor. So this is the LED display. Currently, large number of electronic devices, both as small and large, use LED display as a screen and as a interaction medium between the user and the system. Let's see what are the difference between LCD and LED here. LCD stands for liquid crystal display, whereas LED stands for light emitting diodes. All the LCD are not a subset of LED TV, whereas all the LEDs are the subset of LCD TVs. LCDs primarily use fluorescent lights, whereas LED use light emitting diodes or LED lights for the source of backlighting. Fluorescent light are usually placed behind the screen, whereas light emitting diodes are usually placed behind the screen and around the edges too, for a better imaging. LCDs are usually thicker and lack energy efficiency compared to LEDs, whereas LEDs are much thinner and are much more energy efficient. So it says it is less um, electricity or power consumption is less in LEDs over LCDs. So these were the difference between LEDs and LCDs. Next we will come to the BIOS. So what is BIOS? The BIOS or basic input output system is a ROM chip found on the motherboard that allows you to assess and set up your computer system at the most basic level. The BIOS includes instruction on how to load basic computer hardware. It also includes a test referred to a post. What is post? Post is power on self test. It is a program diagnosis. It is a default program diagnosis that says that all the components of the system are working properly or not when we start the system. So it helps to verify the computer meets the requirement to boot up properly. If the combination, if the computer does not pass the post, you hear the combination of beeps indicating what is malfunctioning in the computer. It initializes the computer's hardware as the computer is being booted. Some of the functions include Some of the functions of BIOS include post, bootstrap loader, BIOS driver, BIOS setup or CMOS setup. So what is post? We already have discussed. It is the test the computer hardware component and makes it is the computer hardware component and make sure no error exists before loading the operating system. What is bootstrap loader? It is to locate the operating system. If a capable operating system is located, the BIOS will pass control to it. The BIOS driver, the low level driver that gives the computer basic operational control over the computer's hardware, is BIOS drivers. The BIOS setup or CMOS setup. CMOS is the user configuration program. It allows users to configure hardware settings, including system settings such as computer passwords, time, and date. So these are all functions of BIOS. This is the end to the slide. In our next slide, we will be discussing about SMPS, that how power is been supplied to the system and how it is maintained. This much for this slide. Thank you.